Chapter 11, Lesson 3. This is discussing direct variation and inverse variation. We have talked about direct variation in the past. Direct variation is the same as a proportional relationship. You spent quite a bit of time on that in 7th and 8th grade. So a proportional relationship is a linear relationship that goes through the origin. So you can see from the picture on the graph, your y-intercept will always be 0, 0. And then it is a constant rate of change. So again, that is direct variation. I'm going to talk a little bit about each of these 3 items here that are separated with the commas. K is the letter they're giving you for constant rate of change. If you look at that, I'm thinking you think y equals mx. So it is exactly like y equals mx plus b. But like I just said, the b is always going to be 0. So there's no need for us to write plus 0 on the end of there. M is your slope, m is your rate of change. In this case, it's your constant of proportionality. So this right here is your rate. They're using the letter K. It'll be increasing if K is greater than 0. You can see that your line's going up right here. Well, as you know, on a line, you have an infinite number of points. Points looking like this as a coordinate pair. In order to get your constant rate of change, you can take your y value in any coordinate pair, divide it by the x value to get your constant rate of change. That might sound confusing to a whole lot of you, so I am going to use numbers so that it makes a little more sense. Let's say I write the equation y equals 5x, and that's a linear equation, okay? Y equals 5x, and I go to make a table out of that. I'll make it like this. Okay, if I put a 0 in, if I put a 0 in for x, I will get 0 back. If I put a 1 in for x, 5 times 1 is 5. If I put a 2 in for x, 5 times 2 is 10. Put a 3 in, I get 15. Put a 4 in, I get 20, etc. Okay, so this would be the table that goes along with y equals 5x. This over here, which I think seemed confusing to begin with, I want you to see how these match. So if I take the y value of each pair and I divide it by x, so 5 divided by 1, 10 divided by 2, 15 divided by 3, or 20 divided by 4, every single time I get the number 5. So k is my 5. Y equals kx. K is 5. It's 5 because when I take every y and divide it by x, y divided by x, I am going to get 5. So that's the connection there. If the directions ask you to find the constant of variation, they're asking you to find the value of k. In this case, the constant of variation is 5. If they ask you to write an equation that relates your variables, this is the equation. So I'm going to say this. This is your equation. This is just how to solve for k. I'll discuss this more as we go. Okay, so that's direct variation. Direct variation is a linear relationship that goes through the origin. Inverse variation is not linear. Okay, so it looks like this. You have a curve. The equation looks like this. I am going to use y equals, let's say, 24 over x as an example for you. So I'll do it over here. Y equals 24 divided by x. If I can separate this a second, this, sorry about that, different color. Everything above the red line is for direct variation. Everything below the red line is going to be inverse variation. Oops, and I wrote that wrong. Y equals 24 divided by x. Okay, where 24 would be what my k equals in this case. So if I go to make a table, you cannot write a 0 in here for x. You can't start with 0 because we can't divide by 0. Again, this is for inverse variation. So no 0, can't divide by 0. You'll start with a 1. Again, I'm dividing. So 24 divided by x. So 24 divided by 1 is 24. Put a 2 in. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6, etc. See how these numbers are decreasing, but there's a bigger gap here than there is here, than there is here. The gap gets smaller and smaller and smaller as you go. That's why it's making this curve. Also, the connection between x and y is if you multiply x and y, 24 times 1, 12 times 2, 8 times 3, 6 times 4, you get 24 every single time. So multiplying the x and y times each other gives you k for inverse, but dividing the y by x gives you the k for direct variation. This is how you write the equation. This is simply how you solve for k. And the k is the number that's in your equation. Okay, so down here, y equals 24 divided by x would be an inverse variation. Notice your variable, your x is in the denominator. You're dividing by that variable. That's what gives you that curve. If it asks you to write an equation, you're going to write it something like this. This is simply how to solve for k. If it asks you to write an equation for direct variation, this is the format. It really should look linear. This is simply how to solve for your number for the constant of variation. Okay, so example 1. When x is 3 and y is 12. So they're just giving you a coordinate pair. Find an equation. All right, so we have to write an equation. It's going to be one of these two. We're going to write an equation that relates x and y in each case. Here's what they're telling me. They're giving me a coordinate pair. So they're saying if x and y vary directly, write an equation. If x and y vary inversely, give me an equation. So let's start with direct variation. This is what the equation has to look like. I need this as my answer, but I have to solve for k. How do you solve for k in a direct variation equation? You take the y and you divide it by the x. So if my, I'm going to just write this down here. My 12 is my y. I do 12 divided by 3 to get my k. If my k is 4, there's my equation. Y equals 4x. Ta-da. Directions. Find an equation that relates x and y. This is my answer. Y equals 4x. I have to write an equation for varying directly. This is what your equation is going to look like. Y equals some number. That's the number I have to find. I don't know what it is. Divided by x. How do I solve for k in an inverse variation? I multiply the x and y. So again, if 3 is your x and 12 is your y, and you have to multiply them to equal your k, then 36 is what that number is. 36 is the number you're putting in here. Y equals 36 divided by x is the equation to have that point on it if it's varying inversely. Okay. Example 3. easy. Again, if you don't have any graph paper at home, well, I did put your notes, like I uploaded your notes again in Google Classroom, but if you don't have any graph paper, but you do have a printer, free graph paper, look up printable free graph paper. There's all different kinds of graph paper that you can print at home. If you can't, you're going to have to sketch it out how I dislike, but I will accept it because I understand the circumstances. Compare the direct variation model and the inverse variation model you found in example 1, which is what we just finished, using x equals 1, 2, 3, and 4, which I basically, well, I guess I didn't write out the tables for that, did I? Okay, so numerically, we're going to make a table for both of these. Try and find out how I can put my hand on here, I guess. So we're going to put our x values in. They're saying that they want us to use 1, 2, 3, and 4. So 1, 2, 3, and 4. Not too many numbers to put in. We might go further than that. So my direct variation, my y values, and my inverse. Don't say indirect, it's inverse. Okay, so on our first example for direct, we had y equals 4x. And for inverse variation, we had y equals 36 divided by x. You want to write that for your table. You can hit pause anytime you want, catch up, and fill in your table. Okay, so if I put a 1 into y equals 4x, I am just 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And 4 times 4 is 16. I'm going to keep going. I'm going to put a 5 and a 6 on here. I know it said 1, 2, 3, and 4. I just want to show you something. So if I do 4 times 5, I get 20. If I do 4 times 6, I get 24. All right, inversely. So I'm going to take each x value, and I'm 36 divided by the number. So 36 divided by 1 is 36. 36 divided by 2 is 18. 36 divided by 3 is 12. Interesting. 36 divided by 4 is 9. 36 divided by 5 is 7 1/5. Trust me on that one right now. And 36 divided by 6 is 6. We're going to see what this looks like as a graph. And then because it says they want us to compare this. Okay, so we're going to graph both of these on the same grid. I'm going to go by 2s. 2, 4, 6, 8. Okay. Okay, so I'm going to start by graphing the direct variation, which is y equals 4x. You can go ahead and say 0, 0 for the direct variation. 1, 4. 2, 8. I am graphing these numbers right now. 3, 12. Oh, I forgot to graph 2, 8, sorry. 3, 12, 4, 16, 5, 20, and 6, 24. All right, if you don't have a ruler at home, of course I do, because I'm a math teacher. If you don't have a ruler at home, you can use a straight edge. Always recommended. arrow. All right, so there's your direct variation. Inverse variation, I am going to be graphing 136, 218, so I'm taking out this middle, 3, 12, 4, 9, okay? So 136, here's 1, all the way up to 36, 218, that's a pretty big drop right there. 312, not as much, I already have the 312. 4, 9, 9's going to be halfway between 8 and 10. Here's 8, here's 10. So 4, 9. 5, 7, and 1/5. That's going to be a weird one, but 2, 4, 6, 7's in the middle. 7 and 1/5 is not too far away from there. 6, 6, 2, 4, 6. You can see how that's leveling off there. So your curve is going to look something like that. Okay. So direct variation, the graph is a line, straight line going through the origin. We should write that, I guess. It says to compare the direct variation model to the inverse variation model. So if I'm comparing, let's see, that's not what I want. Direct is a straight line. Through 0, 0. Inverse graph is a curve. I would say as x increases, meaning as you go across your graph this way, what does the y value do? The y, it values, I guess I should say, but the y decreases. I'm going to say by less each time. That's what makes a curve. Do you notice this big decrease? This is somewhat large as well, but not as much as this went down. And then went down, but by not as much. Went down, but by not as much. Went down, but by not as much. That's what I'm trying to say there. Okay, so and this also says direct and inverse variation models represent functions. True story. This is a function because for every number you put in for x, you only get one value out for y. This is still, an inverse variation is still a function because for every value you put in for x, you only get one value out for y. This says that the domain excludes 0. That is on inverse variation because you cannot divide by 0. All right, example 3. Decide if the data in the table show data. I'm trying to think of grammar there. Direct or inverse variation. What do you do with x and y? X and y together. Okay, what do you do with the x and y to get direct variation? So go back to your table. Let's look at this one up here. What do you do with the x and y to get k? It's always the y divided by x. 4 divided by 1 was 4. If I divide, I get 4. If I divide, I get 4. If I divide, I get 4. So direct is y divided by x. So y divided by x is always the same. Always equal, question mark. Or when you multiply x times y. I'm going to just say, so down here, 12 times 12, 8 times 18, 36 times 4, 16 times 9, 24 times 6 always gives you 144. So when you multiply your x and y, is that always equal? If yes, this would be inverse. If this is yes, it is direct. So now let's go to that table. What do you think? When I look, 12 divided by 1, 12 divided by 1 is 12. 6 divided by 2 is 3. 4 divided by 3, not the same thing. Okay, these are not equal if I divide. Multiply them. 12 times 1, 12. 2 times 6, 12. 3 times 4, 12. 4 times 3, 12. So when you're multiplying the x and y, you're getting the same number. That means this is inverse. All right, decide if it's direct or inverse. So it is, ding, 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 it's an inverse relationship. Write an equation that relates an inverse relationship. So on page 1, I had said, got it right here. If you're going to write an equation for an inverse model, it looks like this, with whatever your value for k is on top, k divided by x. In other words, I need an equation that looks like y equals something over x. How did I find that constant all the time? It was x times y. Multiplying this gave me 12. This is the equation. Okay, question number 1, decide if it's inverse or direct. Inverse. Question per se, I guess. Number 2, write an equation. This is your equation. Has to have an x and a y in it when you write your equation. And a number for the constant. I'll just leave that there a second if you want to pause it. If you want to go back and look at that, screenshot, whatever. All right, last page. Looks like I got 11.4 sitting out here. Okay, example 4. A real life problem for you. Actually, my husband and I over Easter break painted our whole basement, so how long did it take the two of us to paint our basement? That's kind of what this is about. The graph models the relationship between the time needed to paint a house and the number of painters needed. For the values shown, the time needed, t, and the number of painters, n, vary inversely. You can tell this is an inverse variation. You've got a curve coming down. And if you just think about it, if you're talking about painting the outside of a house, the more people you have to help you, the less time it is going to take. That's what's happening here. Time is decreasing as the number of painters is increasing. Find an inverse variation model that relates the time and the number of painters. So we'll say time, number of painters. Okay. And they give you one point that is on this graph. The point is 6 and 4.5, x and y, or if you would like, n and t. So 6 would be your number of painters. And 4.5 would be your time in hours. 4.5 hours if you have 6 painters to help. So it says to find an inverse variation model. Writing a model means writing an equation. And from the front page, you know that an inverse variation equation looks something like this, but you have to find this number. How do you solve for k when you have to write an inverse variation equation? Again, just keep going back to that front page. If this is my equation, this is how I solve for k. Multiply your x and y together. These are your x and y values. So I'm going to say 6 times 4.5 is how I solve for k. And when I multiply 6 times 4.5, or 4.5 sixes, I get 27. Really what this means too is if you only had one person or you were going to paint by yourself, it would take you 27 hours. Okay, 127. I guess you can't quite see that on the graph, but sort of. It'd be right there. All right, there's your inverse variation model. Use the model of to find the time needed for 4 painters. your painters, oh, I could write this too as time equals 27 divided by your number of painters instead of X and Y. So 27 divided by 4. And 27 divided by 4 is 6.75. 6 3/4. Or 6 hours and 45 minutes. Use the graph to describe how the time needed changes as the number of painters decreases. So if your painters are decreasing, the amount of time it takes you to paint the house increases. So you're writing this something like as the number of painters decrease. Oops, sorry. The amount of time it takes to paint the house increases. You have something like that, but if you can write it as a as this then this kind of thing. So again, as the number of painters decrease, fewer painters, the amount of time needed, you could say to paint the house, you want to add words, it's fine, but the amount of time it takes you to paint the house increases. Okay, that is 11.3. You need to do from page 659, 13 to 35 odd, 37 and 38. All right, have at it. This is not due until Wednesday. So I have some kids asking me if I'll post more and more lessons. They just, I guess, want to keep doing math. But so this is due Wednesday.